Now we are going to get into the question of a projection. So a projection of a force on an axis is the component, or rather you should think of it as a shadow of that force that acts in the direction of this axis. Alright, so mathematically it is found by multiplying the magnitude of the force by the cosine of the angle between the force vector and the axis directions. I will tell you about that in a second. So you need to understand that it's like a shadow. So you imagine that you are shining a light perpendicular to the axis. The shadow of the force on the axis is the projection. Okay, so yeah, and we also have the unit vector method, which is going to be, if you have a force, and we've discussed this when we said that F is going to be equals to F across a certain axis. Okay, now let's start with the question. It says determine the magnitude of the projection of the force is equals to 600 Newton along the UX axis. Okay, so to do that, what's going to happen, you are going to use the dot product. It's a scalar projection. So you're going to say F along the U axis is going to be equals to U. Actually, let's say F dot U. It does not matter how you arrange them. So I'm going to have my certain U axis. So the U is going to be what? It's going to be the unit vector. And we do understand that the unit vector has a magnitude 1. So unit vector has magnitude equals to 1. And because it's a vector product, a vector dot product to be precise, the F needs to be expressed in terms of its components. So what is F? By its component, recall that I'm going to need what? I'm going to find a position vector that describes the direction of the force F. Okay, and it's this direction. Just recall that the magnitude is equals to 1. I'm removing this. So just remember that magnitude of this vector U is going to be equals to 1. Keep in mind. So now I need to find the direction vector from O to A. Okay. In other words, I need to find the unit vector in the direction of OA. So that's where I'm going to start. The unit vector in the direction of OA. First, let me start with the position vector OA. So it's going to be, what are the coordinates of A? So we move how many units in the x direction? We can see that it's going to be negative 2. What about in the y direction? We can see that to get from O to A, we need to move 4 units. What about in the z direction? We move 4 units up. So it's going to be negative 2, 4, 4. Now we do have OA. So the magnitude of OA is going to be equals to the square root of what? Negative 2 squared plus 4 squared plus 4 squared. And then when you put this into your calculator, and then, okay, it's going to be 4 plus 16 plus 16, 32 plus 4, 36, which is going to be 6. Let me confirm with the calculator. Yes, it's 6. So now what's going to be our unit vector in the direction of OA is going to be equals to negative 2, 4, 4 divided by 6, which we are going to get to be 1 over 3, and it's going to be 2 over 3, and this is also going to be 2 over 3. So yeah, that's the unit vector OA. So to find the vector F along its direction, so you're going to say F dot U. So So our f is given by 600. Actually, it's not a dot because here we are just trying to express it in terms of its component. The projection is only when we are going to use the dot product. So I'm just going to multiply it manually. 2 over 3 comma 2 over 3. So your FOA is going to be equals to 600 divided by 3, which is going to be negative 200 I. I'm just changing things just to show you that you can alternate between whatever you 1.2 divided by 3 is going to be 12 divided by 3 is 4, so it's going to be 400 J, and similarly this is going to be 400 K. Everything, remember that it's in newtons. So yeah, that's your FOA. Now we can try to get something. Now, in order for us to say what is the force, like remember that the question is saying determine the magnitude of the projection of the force along the u-axis. In my equation here, you can see that I'm going to need what? I'm going to need the force F, which is what I've found here, and I'm going to need the unit vector u. But I don't know the unit vector because I do not have any force or any displacement vector in the direction of u. So what can I do is that I'm given an angle here, and what do I know is that this is going to be the ux component. Let me call this the ux component, and this way I do have the uy component. Okay, and now I need to try and find, what do we call, I need to try to find the unit vector in that direction. So what's going to be, okay, we do know that this angle is 30 degrees, this one, it's 30 degrees, right? So what's going to happen is I'm going to say cos of 30 degrees is going to be my adjacent side. My adjacent side is going to be what? uy, right, over the hypotenuse. The hypotenuse is this side here, which is going to be 1. Therefore my uy is going to be equals to cos of 30 degrees. What about my ux? It's going to be what? Okay, let's see. You can prove it, but my ux is going to be sine 30. Check it, use the triangle, you will see it. Now I do not have a component in the x direction by this unit vector u. It has no z component, I mean. So that means u, the unit vector in the u direction, is going to be equals to cos of 30 degrees, because I multiply everything by 1, right? So it's just cos 30 degrees, and then plus sine 30 degrees. You can try to square to find the magnitude, to square the components, and you will see that you will get a value of 1. Let me see. Then it shows you that since the magnitude of u is going to be equals to 1, it shows you that this is a unit vector. Okay, so now what do we have? We have two vectors now, the u and the f of u. So we have the f and the u. So we are going to take the scalar product. So it's called the vector dot product. So it's going to be f dot u, right? And then you're going to do this component wise. You're going to say f, what is my f? You are given it as negative 200. Let's go back to our notation, 400. The reason I like this notation is because it's more quicker compared to the I notation. So it's going to be cos of 30 degrees, comma, what about the y? It's going to be sine 30, and this is going to be 0. So it's going to be negative 200 times cos 30. What is it? Actually, no, I mixed these things up. Recall that ux is going to be what? Excuse me for that. It's going to be sine 30 degrees. And then what about the uy? It's going to be cos of 30 degrees. Okay, so now it's going to be f dot u. So this is sine 30 degrees. This is going to be cos of 30 degrees. Now it's going to be negative 200 times sine 30 degrees. So we do know that this is 1 over 2, right? And then this is going to be plus 400 times cos of 30 degrees. The other term I do not care about it because it's going to fall off. 400 times 0. Then, okay, it's going to be negative 200 times 1 over 2 plus 400 cos of 30. You get a value of 246.41 newtons. And then that's it for this question.